Special course in TeX82 that we plan to have intensively for the next 3 days. I'm going to give you all an OD on this particular system. This is something I'll probably do only once in my life because I don't know if I'll understand the system as well as I do now at any other time in my life. And I think it's an exciting time for the development of TeX because here's when it's beginning to move out and meet a lot of different kinds of computers around the world. It's quite an experiment in portable software that we're doing, I think, for a program of this kind and at this scale to try to make it work on lots of different machines. And I'm pleased that so many people are participating in this experiment with us. Now, the lectures that I'm giving are on videotape, as well as being, in this live thing that we're doing here. And the people watching on videotape will presumably be doing it after TeX is debugged, because I hope to debug it next week. To finish it next week. So at the time that the people are watching on tape, they'll probably have a slightly different collection of handouts than you do in the audience right now. Now, the three handouts that you were given this morning, one is the write-up, TeX82, and this one, by the time people are watching on tape, I think will be published in a book. Then the first part of that book will contain the TeX user manual, which I haven't finished writing yet. Instead, in the audience, all you people have is a brief summary of what that language TeX82 is going to contain. Then the other two handouts you got this morning, one is this one called the Web System of Structured Documentation, and this is the other one is called TeXware. And the Web System is, of course, the one that we're using to make it possible to do system programming in Pascal and to make it portable. And TeXware is a collection of 4 different auxiliary programs that you'll find useful in installing TeX. The first program is simply to print out the string pool file. We'll talk about that later. Second program is to convert font metric files to a symbolic format. The third program goes back from the symbolic format to the PAC binary format. And the last example is is a symbolic printer of our DVI files, the device-independent output of TeX. Now, by the time people are watching on videotape, I think these two handouts I just mentioned are going to be Stanford reports. And so they, if I refer to those, that'll mean a certain Stanford report. Finally, at the end of your blue at the end of your TeX82 listing, there are some appendices, and those will probably be published in Tugboat by the time anybody watches this tape. The appendices are related to a test program for the system, and the idea will be that somebody can run this test program on the system and compare their answers to what I think the right answers are. And so we'll be talking about the test program later on too. Well, those are the sources for the thing. Now as far as the organization goes, we have 3 days here and 4 hours each day. We're going to meet 9:30 sharp. We're going to start at 9:30 sharp every morning, and 2 o'clock sharp every afternoon. And we run 9:30 to 10:30. Take a break till 11. Start at 11 sharp. 11 to 12 o'clock, then break till 2 o'clock, then we'll go 2 to 3, and 3:30 to 4:30. That's what I meant by overdose of this thing. Now, in this time, I expect that I'll be able to make you familiar with it, so that you'll feel that you understand what all this document is doing. At least where to look for the other answers. Not that you'll have proved it correct in your mind or anything like that, but I believe that it's possible in about 40 hours of reading, not counting coffee breaks, to just go through and actually understand each module of the code and convince yourself that it's actually working. and of course, hardly anybody is ever going to do that. You'll just skim it and say, well, if I ever need to know about this module, then I'll look further and understand it. But if you had that as your goal, suppose that I was, for example, having a contest to see who can find each remaining bug first, and I was giving out $100 for every winner like that. If you had to do that, I think you would get to the end of it in 40 hours, and if you were motivated. Well, that's a rough estimate as to how much it might be to comprehend all of this code. Now, the computer file that generated this book was about 750,000 bytes long. And so that's about how much chance there was for typographical errors in it. Each one of those bytes could have been mispunched, and then there's a chance for bugs too. And so on. It's about as correct now as it would be if this was a book on mathematics, which had theorems and proofs in it. Unfortunately, computer programs also have to work, and so I'm not quite there to that level yet. Now, I know that people in the audience here have a large variety of backgrounds. Some people are at least 3 of you, I think, have implemented the previous version of TeX, know every byte of that implementation, and on the other hand, there are people here who probably won't be writing the system code themselves, but they want to use TeX heavily, and they just want to get a good feeling for what's inside of it. And now, so how can I make everybody happy in this way? Well, I think probably that my best strategy is going to be to not go too fast, but to those in the audience who are going to be users and not system people should try to imagine that they were system people. It won't hurt. Just to keep that in mind, as if you were going to implement it. You don't have to afterward, but it gives you the right frame of mind to understand the kind of questions. Because what we're going to do is we're going to consider as our goal to understand this complex piece of software, and to look at and to see how the different parts fit together with each other, and then we'll get even if you're only going to be a user later on and not ever touch this code, you're going to have a pretty good feeling for how this complex piece of software is going to respond when you use it in certain ways. Now, the four lectures that we're talking, the 4 things we have today are the fundamental ground level things on which we're going to base things later. Don't miss any of these. The first hour is listed as reading web programs, and the next hour representation of strings inside the program. The third, it will be the data structures for boxes and glue, and the last will be representation of control sequences. And those are, in other words, the key things. First, we're going to find out how to read the program, and then we're going to find out how it represents things inside of itself. In order to get any further, we have to see how the inside of TeX looks, so that we can see how it deals with the things that we know appear on the outside. Tomorrow's lectures are going to be about the main processing routines of TeX, the syntax routines at the beginning. Then the semantic routines, and then in the afternoon I'm going to talk about how TeX breaks paragraphs into lines, and how it does hyphenation. On Friday we're going to have 4 lectures that are primarily addressing the system-dependent issues, the things that are most important to the people who are going to be installing TeX, and those, in other words, the things that are most critical to the portability question. And so the first hour is talk about scanning of file names, because we want to make TeX fit in with the local operating system, and every operating system has different ways of referring to these names. Then we're going to talk about the font metric files and what they look like inside, so you can understand TFM files. In the afternoon, we're going to talk about the DVI files and the problems of initializing the production program, getting it going in the first place. So those are all things where we're really bit pushing pretty much on Friday. Namely, the file names is a syntactical problem that's different at different installations. The TFM and DVI files are binary files that you have to understand because they'll be on your systems. And then we have to also talk about what you do to bring the bootstrapping process of bringing things into existence. Okay, any questions so far? Now, I was delighted yesterday to get in the mail the new August edition of Computer Magazine. It has a cover called The Evolution of Ethernet, and maybe I can flash that. Well, no, you won't be able to see it. I'll just hold it up. We might be able to get it on the screen later, but it's got a beautiful picture of a web on it with droplets of water on the web, and it's just like you'd find in the Sierra Club calendar or something. And what I'm talking about the first hour is the web system of documentation, and web is here thought of as something that's not going to ensnare us, but something that has a structure, a network structure. In fact, they use the web to illustrate Ethernet, which is probably doesn't have that structure at all. But web and net are somewhat linguistically related, and they're related also to TeX, as we know. Now, so I'd like to explain how to go about reading this document. As I said, there were some appendices at the end. That doesn't count as part of the web description. But web is the system that will take my web source files, and then I run Tangle or Weave on the source, and I get either a Pascal program or a TeX program. If I run Tangle on it, I'll illustrate Tangle in a minute if the computer is up, and if I run Weave on my web file, I get this book. I'll have to TeX it, and then I get this book. Now let's see, is the computer? Yeah, the computer seems to be up. So let's try to switch over to the computer screen, and I'll illustrate what Tangle looks like when it's running. One thing you have to do in order to use web is to have a Tangle program working. So we have the lights down, and let's see if you can see the computer screen. Okay, now let's see, am I in the right file? Okay, can you see at the bottom of the screen there, I've said something with Tangle. The contrast won't be very good, but it's asking me for, well, let's see, we should be able to get that up higher in the screen in a minute. It's asking me for the name of a web file, and I will call for Tangle Web. That's on my area web DEK. It's asking me for a change file. The change file is where you will put in your modifications that you would want to use at your particular installation. I'll just use null for a change file now. Can anyone see that at all? Okay. Is it okay? Now my output is, I'll put on Tango PSC, for example, that's what we use for suffixes there, and it's asked me for a pool file also. And I don't need a pool file in this case. Now, a pool file is where it would put strings if there were strings in double quotes in the listing that have more than length 1, because Tango will do this. Now let's see if we can watch it operating here. It's printing out as it gets to a starred module. These are the ones that have come out in boldface type and in the table of contents in your web listing. It prints out the number of that module as it gets to it, so we can see what it's doing. And it's tangling itself right now because it's tangling from Tangle Web. So this is converting the web description of the program into a Pascal program. And first of all, it reads the whole thing into memory, into a very compact form inside of itself. And now it's writing the output file. Every time it prints a dot, it's done 100 lines of output, of Pascal output. Okay, so there, 500, okay, you got it. And so then when we get the output file, we should be able to run Pascal on that. Here it's also giving us some statistics about, let's see, I can put that up higher on the screen. It told how large it needed for its memory, and it stored that whole Tangle program in approximately 18,000 tokens. Those are 8-bit. Those are 18,000 bytes to represent the Tangle program in its compact form, plus what is called byte memory. And the Tangle program is in one of those handouts that you have. Now, since we did that successfully, let's try the same thing on TeX. So we'll try to Tangle TeX. And here we TeX is a much larger program, but I have to show you illustrated graphically, so we do this. So TeX web, and again, I won't use any change file, and we'll go to TeX Pascal. And now the pool file, we'll put it in tex.pool, and or tech.pool, of course, and then at our particular system, extensions like pool can only really be 3 letters long, so that's going to be called poo. All right, so it'll go run for a while, but it'll be generating a Pascal source for this program. Now the web, the listing that you have of TeX begins with a table of contents. So very first, as you open that cover, you'll see that there's 55 parts to the program, and number 1 is the introduction, and the last one is the index. So these are the major substructure to as far as TeX82 is concerned. We're going to be talking about, for example, string handling, part 4. That'll be one of the things we talk about the next hour of the lecture. I want to recommend that when you read this, you start in section 1, and then go to number 2, and so on, instead of starting at section 400 and something like this. Now, there are some places to start that are worse than others, and I think the section on alignment is the worst of all. If you try to start reading TeX by learning how it does H-align, I think that it might take, 400 hours instead of 40 hours to understand what's going on. Because alignment is done in something like post-hypnotic suggestion by somebody who plants little ideas into the other parts of TeX, and every once in a while they come into action and do the right thing. But it stands in the background most of the time, and it sort of lets everything else happen, and automatically will rise to the right occasion at the proper time. That's the kind of thing that I couldn't write first, and you shouldn't read first. But especially, I intended it to. I actually presented this pretty much in the order that I wrote the program. Almost in that order, because I wrote the program in a way that I felt it called to be written. It's saying that now, before I go any further, my mind won't be at ease unless I do this. I want to know how this is going to happen. I got to do this now. And or somehow, I don't know exactly why I felt that way, but I did usually feel rather strongly at what needed to be done next. And I think also for reading it, similar questions would be in your mind that this is what you might want to know next as to what to do. So it's a combination of a bottom-up and a top-down approach, where first I go bottom-up and build up a lot of tools that I'm going to need later. I know I'm going to need those tools, but as I work on a particular tool, I probably approach the building of that tool from a top-down direction. Now, the thing is a total of 1,244 modules, at least at the present time, and after I finish debugging, it'll probably be 1,245. And these modules all are numbered, so you can see that usually we get several modules on a page. And as I turn over, we can see different modules over and over, and each one has a nice big bold-faced number on it. And up in the middle of the page here, you'll be able to see the part number and the module number. So there will be a little section sign in between. So like this says 35, part 35 in module number 652, okay? And this is the part that's doing typesetting of math formula. This whole listing, of course, was generated by computer automatically from the web file. Now, at the end, we have an index, and the index shows every occurrence of every identifier in the program. And then there's underlined ones. The underlined ones indicate where that identifier was defined. So let's take this. There's other things in the index besides identifiers. We'll talk about those in a minute, but let's take this one, empty. So empty is defined here in module 588. So 588 is underlined, and it's used in all of these modules here. We aren't going to look them all up, but let's check out 588 and see what empty is doing in 588. And it turns out that there's a definition of empty here, both in text, where it explains that what empty means. Math type empty indicates a field with no value. Oh, you can't see the things that people on the videotape can see. I'm sorry. I've been assuming that you could read a little bit what I see on my monitor here. Meanwhile, by the way, TeX is tangling up to module number 749, and we're time sharing and getting 15% of the machine, and the load is 4.5. Okay, now anyway, I was saying that if we look in the index, if you look in the index, then it should refer you to where things are defined and all the uses of them. Except if letter is only one, if it's only one letter long, then the index only gives the underlined references to it. It doesn't give anything else. So if you see in the index, for example, I probably have a letter F all by itself. And so under F, there will be lots of underlined entries for F. Well, that's wherever F was used, was declared, probably as a parameter to a procedure or a local variable in a procedure representing fonts. Because one-letter identifiers are intended are probably used so often that nobody would care to see them in the index. Okay. Now, the other things that appear in the index are error messages. So if you see an error message come out of TeX and you want to say, well, where in the heck was that error message generated, then this will tell you what module to find that. And a few things you'll find. Well, reserved words you don't often find in the index unless I specifically said I wanted to indicate that the word begin is used in this module in some interesting way. But usually Pascal's other words, of course, won't be indexed. By the time the book is published, we expect that there will be a lot more entries in the index that will key you into where TeX does various operations. So if you want to see where does TeX handle something like lowering a box or something like that, you might look up in the index under lowering a box, and it might be there. I'm going to try to go through this as I do with other books and try to figure out what ought to go into the index of the book, but I haven't done that yet very much. So other kinds of index entries that are just in Roman type, there are only a few of them so far, and those will be like there's one entry here for Chinese characters, and it says Chinese characters are discussed in modules 128, 457, 500, and you can, if you're interested in extending TeX so that it would deal with Chinese characters, suggestions for doing that are in those modules. Now, each module, except the index, has the same basic structure to it, and it's a three-part structure. There's the first part is TeX. The second part is definitions of macros, and the third part is Pascal. Now, not all modules have all three parts. They can be empty. You might not have a TeX part, you might not have a definition part, you might not have a Pascal part, but but you never have more than one TeX part. You never have definitions after the Pascal part. You never have a TeX part. It always has that order: TeX, definitions, Pascal, and they might be absent. This is something that turned out to be a fairly good, easy thing not only to implement, but also to it was approximately the way I was writing code when I tested this out when I was sketching out the ideas of web last fall. Now the TeX part then is expository. It's supposed to explain either what the whole idea of what's going on now and in the future, or it will explain some less obvious point about the code that follows, perhaps telling you the environment of the code, telling you what's supposed to be true at this point, reminding how we got here, things like that. States some kind of an invariant of a loop that'll be there, explain why that loop might be expected to terminate. Saying why I didn't do such and such. The comments at the beginning depend on what I think is worth saying. I try to think of something interesting to say in every module that has Pascal text that's going to be contributed to the main program anyway. The definition part defines macros. I'll talk a little bit more about that in a minute. That's a key thing to understanding a program written in web. And then, of course, the Pascal part at the end is Pascal code. I try to shoot for about 12 lines of code in these as a maximum. Sometimes I go up a little more, but I try to keep it to something that you can understand as a unit. The idea being that if you have faithfully come into this module from the previous ones, you should be able to know enough about it, about the current subproblem and what you're supposed to do in this module to fully understand it in terms of these 12 lines. Just by looking at these back, maybe your eye would go back and forth over the 12 lines a few times, and then you say, "Oh yes, I got this. This makes sense to me." So the modules are small enough that you can perceive their structure and perceive the whole idea. They refer to other modules in different ways. Let me see. I'll take a sort of a random. I just turned to module 180, which is on page 59 of your handout. I just chose it at random, and it said display the value of glue set of P. And so that's a little module that is actually, I might tell you that it's used when we're trying to print out, P is pointing to a box, and we're trying to print out what the glue setting is. This is the ratio of how much the glue has to expand. And if the glue is going to be expanding by a non-zero amount, we want to indicate that amount of expansion, because this is part of the diagnostic output to explain one of TeX data structures in symbolic form. So the code then says if glue set of P is not 0, then we will print comma glue set. Now in those double quotes in the print statement, print double quote comma glue set, you see that this is one of those strings that I mentioned before, strings with double quotes. Pascal uses single quotes for strings. Tangle makes those strings and puts them into a string pool file. In fact, it has finished now, and it said it wrote 897 strings to the string pool file. So there are 897 different strings in the program. If I use the same string several times, it will, of course, do it only once. Now, Tangle converts that to an integer, and the integer that it uses starts at 128, because 0 to 127 are reserved for the single character strings. And there's an internal code, and it's essentially ASCII code that's used so that if you had a double quote A, undouble quote, that always refers to ASCII code of A. It doesn't refer to your local EBCDIC or whatever code you might be using. That always refers to ASCII code of A. We'll talk about character set problems later on when we talk about strings. But so anyway, this is a number. So when I says print double quote glue set, end double quote, that's really in the Pascal file. It's going to say print 428 or some other integer will be in the Pascal program. Then we check and see if the glue sign of P is shrinking, and we print a minus sign to indicate it that the glue is shrinking instead of stretching, you see. And then we have problems to see whether we're going to print out some value. If it's real large, then we're going to print out greater than 20,000 or less than 20,000, something like that. Anyway, that's the way the program works here. And it says at the bottom, this code is used in section 178. So if you need to know where this module was applied, it was over here in modules 178. 178 indeed applied it here, display the value of glue set P. And in that module, that module was display box. And so P is pointing to a box, and we have in this module the problem is how to display a box, and that breaks down into subproblems. And so let's just read through that code so you get the idea. So you look at see what kind of a box it is. It's going to be either an H-list node or a V-list node. We'll talk about data structures this afternoon, but that means it's an H box or a V box essentially. So we're either going to print H or V. The H is going to be the ASCII code H, because this is a one-letter string, you see. Print escape means that it's going to prefix it by a backslash. It's going to print a backslash and an H. Otherwise, if it's a V-list node, it's print a backslash and a V. Otherwise, there's something called an unset node, which is used in alignments. And then we have a box and a left parenthesis. Then it'll print the height of the box as a scaled number. We'll talk about these things later. And then so it prints the dimensions, the height, the depth, and the width. And then it will check if it's an unset node, it has to do something special. Display special fields of the unset node P, and that's module 179. Which we don't care about for our purposes now. We can say, okay, that's going to be something that's going to display those special fields. Otherwise, we will display the value of glue set P. That's the one that we looked at first, and that'll say whether it's stretching or shrinking. Unset nodes don't have glue sets. That's why we do it differently. And furthermore, it don't have shift amount. This is whether the box was shifted up or down or something like that. And so we check and see if it's shifted. So that finishes this. Module 178, it referred, you see, to modules 179 and 180, but if we had to actually stick the code in there, it would be a distraction. So we don't want to, so for now we concentrate on what do you do when you display a box? You have to go through that many operations, and then you've done it. This code is used in section 177, which indeed is called display node P, and it breaks down, it's a case statement that has many subcases. The first three cases were H-list node, V-list node, unset node, said display box P. That's where we did this. Or we had to display a rule or insertion or all these things we have to possibly display. And there's another module here that fits into the case statement called cases of show node lists that arise in M lists only. This is when you're trying to display something in math mode. And it only occurs in math mode, so we don't even write it in this part of the TeX program, since it's a person reading it doesn't know about math mode yet. In fact, when I wrote this part of it, I didn't know about math mode yet myself. So I just made a module saying, well, I'm going to handle those cases later. And in 596, we'll have indicated the exposition will have explained what math mode is like. And so there will be display instructions in there. And that will be patched into the program by Tango at this point. So we'll have a case statement that also includes other cases for things like square root signs and so on that have to be displayed. And then it says other cases print unknown node type. And this is something I'll talk about with respect to what you do in the case statements in Pascal if they it really means all other cases that haven't been listed here. And this code was used in 176, and if we look at 176, it doesn't tell us where it was used. In 176, it just ends at the bottom, says it doesn't say where it was used. If it doesn't say where the code was used, this means it's really on bottom level. This is part of the whole Pascal program itself. And so the things on bottom level are strung together in the order that they appear here. So this module 176 will follow the previous code for bottom level in in the program. Any questions so far on this? Now the macro definitions is something I've got to talk about next. Let's take a simple case of macro. There are three kinds of definitions, and they all say define. The one is numeric definition, and then there are there are definitions that substitute with or without parameters. Those are the three kinds of definitions. Let's see if I can find a example. Okay, numeric definition. I'm on page 51, module number 156. Has lots of numeric definitions. I'm laying out the memory, and I'm giving symbolic names to specific parts in the memory. So I define zero glue. Oh, this is not a numeric definition. I'm sorry. It has if it has three lines, if it's an equivalence instead of an equal sign, this means it's a text substitution. Because if it's just an equal sign, that means it's a numeric thing which I'll compute at tangling time. But this is a text substitution because mem base is a compile time constant. It's something anyway that I didn't think I could necessarily know. So I've used three arrows here, and then I define fill glue to mean zero glue plus glue spec size. Anyway, these are things that have been defined elsewhere. This is an example of a definition, and whenever I say temp head later on, it's going to mean high mem base plus 3. And this will be a more mnemonic way to refer to temp head. And the comment says it's a head of a temporary list of some kind. So each of these things we try to explain it in words as we define them. On the previous page, you'll see a simple numeric definition, define unset node as 13. So that's the type for an unset node. And that's followed by the other two kinds of definitions. So we have all three of them in that module. That's nice. The glue shrink is to be substituted by shift amount, which, by the way, is a macro itself. So eventually it'll propagate down to low-level Pascal code. Glue stretch of its parameter is mem of that parameter plus 6.sc. This allows us to refer to Pascal structured types in a way that's mnemonic, indicating that we're really looking at the seventh word of something that starts in a given location, and we're looking at it as a .sc field of that word, and if we were rewriting text for some other memory configuration, we would only have to change this definition of glue stretch and to say how we actually are representing it in whatever language we're really programming in, because the rest of the program just talks about glue stretch of something and doesn't know that it happens to be in words something plus 6 of that. So these are the three kinds of macros. The constant macros are restricted that these numbers can't get too large. I think it's something like 15 bits plus a sign, so that I shouldn't define with an equal sign something to be. I'll never define with an equal sign something that's a number like 50,000. I can do 30,000 okay though. The advantage of those small numbers is that I can do arithmetic on them and not put parentheses around if you do text substitution, you can have some troubles if you try to say minus a macro, and then that macro has been defined to be x plus y without parentheses. But if the macro has been defined with equal signs and x and y are numbers, it'll add those numbers together and it'll work. Now, I don't understand how I know when I'm reading my program which of these identifiers is a macro and which isn't. Somehow, I've never been confused by it, but possibly because I wrote the program. It's something that is in the back of my mind to experiment. Would there be a use for some typographic distinction between names that have been defined as a macro and names that are really Pascal identifiers on the low level. Everything eventually propagates into a Pascal code, but who knows? When I'm reading a program on I'm here in the middle of module number 700 something, and it refers to glue stretch. Am I supposed to know that? How do I know that's not a procedure call? It's really it has this. It looks like it might be a procedure call with a parameter, but it's really a macro call with a parameter. Well, partly I think it's because when I'm referring to glue stretch, I presumably know that it means that it's a certain field of a record, and I'm always referring to fields of records via macros, so that I can have a symbolic way to refer to them that isn't too closely tied to Pascal language itself. Anyway, some of the identifiers you see in the program are in the Pascal program. Others are macros, and if you refer to the index, of course, it tells you where it's defined, and you can always check exactly what it means. I've written this so that in the final Pascal program, no two identifiers will start with the same first 7 letters. So Pascal's rule says that they have to be distinct in their first 8, but I made it 7. Partly this helps catch typographic errors, because if two things agree to 7, if I have a typographic error and Tango will print out that there was that these two variables have conflicting names, and it probably was that I made a mistake in typing after the first 7 letters. But it also, it's just because I've heard of compilers that actually put this extra restriction on, that the first 7 should be unique. But this also gives a clue as to whether a name is a macro name or not, because macro names don't have to be distinct in their first. They can be 100 letters long, and the first 99 letters can agree, because macro names are done by Tangle, not by Pascal, and I implemented the full comparison of those names. So whenever I have a long identifier which looks like it has very high chance of conflicting in its first 7 letters with something else, then that's another dead giveaway that it's a macro name, because I would never dare use such an identifier and then freeze those valuable first 7 letters for some other purpose, like I don't know. We'll see examples of that, I'm sure. Okay. Now let's take a look at the very beginning of the program and see how it gets started. As I said, the right way to read this is starting at module 1 and going through. I'm not going to be giving you homework exercises in these lectures, but I would encourage you to do some reading tonight and tomorrow night. You probably get more out of the lectures on Thursday and Friday. The introduction here is primarily historic. And there is one definition at the bottom of the page that defines the banner string. And here's something that will be source of one of your system-dependent changes. Presumably, you will change this so that the version number will also indicate that this is the VAX version or something else. And then this right now is version minus 0.25 because it's not debugged yet. Okay, then. I talk about the idea of system-dependent codes and other things that are in the index here in section 3, and one of the things I mentioned here in section 3 is this idea of an index entry that's called Dirty Pascal. There were a few places where I did things that aren't considered kosher in Pascal. And if we look up Dirty Pascal on the index, it'll show you those modules. And the modules will try to justify why they did the thing they did. Usually it was for debugging purposes, where you had to fetch out a record not knowing what it was because something has gone wrong. But anyway, if your compiler is going to complain about those, you'll want to know about it. Part 4 is where we actually get going, and into the program, and so here's where we first start. This is the first Pascal text. Modules 1 to 3 didn't have any Pascal text. There was just one definition. And the very first thing, well, we have a definition here that I could explain. M-type I define to be T ampersand Y ampersand P ampersand E. And this is a special web thing that will concatenate different identifiers together without spaces between them. And I'm calling it M-type is TYPE. The reason is that I wanted very much to use type as one of the macros that I was going to define later, but it's a reserved word in Pascal. And so in order to do this, I can define M-type for the one or two places where I needed to use Pascal's reserved word. And then afterwards, I get to use type myself because there's a format which is a special kind of a definition that says that the M-type identifier should be treated like Pascal treats type, and type should be treated like Pascal treats true. So that will so for formatting purposes, I can make those kind of definitions also. That's a little thing for web. Now the program itself starts here with compiler directives in module 9, then program statement, and gives the name of TeX. It doesn't have any file names mentioned there, because if it did, on our Pascal anyway, the user would have to type in file names at that point, and that's not the way TeX82 does things. Then comes the labels, and there's a listing for labels in the outer block, section 6, constants in the outer block, types in the outer block. This is where I used my M-type, and you notice now it gets formatted in boldface here. And then var lists globals in the outer block. Then there's a procedure declaration for the initialization. An initialized procedure is going to be called to get things going. And then there's a module called basic printing procedures, which we had to declare very early in the game. And error handling procedures, which we also have to declare early. Because any errors can occur almost anywhere. You have to declare your error handling procedures soon. But while you're doing errors, you have to print out what the error is, so you needed the printing things even earlier. And that incidentally enforced the discipline that when I'm printing anything out, I've got to do something that's not going to have a chance of errors going wrong. So when I write my print procedure, I'm not supposed to overflow any buffers or anything that would cause an error message that would get that might get into a loop. Okay, now that's the way the program starts, and Module 5 explains how it continues. Namely, all the modules from now on is going to we're going to have more declarations of procedures, and finally there's going to be a place called Start Here where we start, and that's going to be way at the end, because we're just going to build up procedure after procedure after procedure, doing the things that TeX is supposed to do, and then at Start Here it's going to say do it or something like that. Call initialize and a few other things, and then it will also tell how to die gracefully at the end. So these modules are further explained later on, and I have special things declared in Module 7 that's for different versions of the 7 and 8, which are for different versions of the same program. This is all one program. Some of you had experience with the previous kinds of TeX, and there were three programs. There was TeX, there was a system-dependent module, and a pre-processing module. Well, all three functions are combined in this one now, and even a few more. And in order to select out different things, we can change these definitions of these modules. Here I have debug and backwards debug. And if I put code between debug and backwards debug, it'll be commented out normally, because I've declared debug to be @left brace, which is a real left brace to go into the program, and backwards debug to be a real right brace. This, incidentally, Tango will now change left braces to other symbols so that it won't. This will still be a valid Pascal comment in between those two braces. But these two and if these were inside of other braces, these wouldn't actually come out as braces; they'd come out as brackets. This is now will comment out all the code between debug and backwards debug. Similarly, there's statistics and backward statistics that comment out code that would slow TeX down, but will keep information about how big its tables are getting. And when you're installing a system, you want to find out how much of your memory is actually being used. You'd like to see these statistics, but it gets verbose if people print them out all the time. It slows the system down, I think, well, maybe 4 or 5%, but maybe you wouldn't want to pay that 4 or 5% if people aren't using the statistics. So that can also be commented out, and it's shown as commented out here. Then here is similarly is the other version of TeX, init and backwards init. These are things that are only present in the initialization version of TeX, the one that you need to get started, because it loads all of the hash tables with the primitives and preloads formats, preloads macros, so it can put everything into a condensed file for efficient starting out of the production program. So you'll have two versions of TeX, production program of TeX and the initialization called initec. And to make initec, you've got it, because this is not commented out. But to get the production version, you have to change this to braces, and you do this in your change file. You never change the web file for TeX. You just make a change file for initec, a change file for production TeX, and you run Tangle with one or the other. Let's see. There will be other changes probably between these also, because initec you'll want to allow yourself more room maybe for hyphenation tables, since you want to see how big those are going to be. And then afterwards, when you have a production TeX, you'll know that the hyphenation tables aren't going to be very big. You can cut that pile time parameter down. So those are the three things that can be compiled. Compiler directives is something rather, most Pascal compilers, if the comment starts with a $, it will do something special like check ranges or not, and so on. So I've done that. Now, I don't know what time it is. I can't see the clock in the back. Can someone tell me so I can gauge? It's 10:30? Okay, so I got only a few more minutes before we break. We started 5 minutes late. So let's take a look at what the computer has done since we did start it out there. So you see that it came to a conclusion, and in fact, where it says idle 25 minutes, that means I haven't done anything for 25 minutes, but the 2 in front of it says that was 2 minutes of CPU time. So it took exactly 2 minutes of CPU time to do this tangling on this TeX 10. And it had little more than 4,500 lines of Pascal code, and the numbers here, and the number of tokens here was more like 110,000 bytes in order to do the compressed thing in memory, and also called tokens. And then things that were called bytes, those are generally strings and names of identifiers. And there's lots of those too. And this is a rather large order for Tangle to fill, but it isn't too bad. Now let's take a look at the Pascal program that was generated. So that's the TeX Pascal. This should be 4,500 and some lines long, and take it a while to read in. For the editor to read it all in, because it's a page-oriented editor, and the larger the page is, the longer it takes. Now, I just wanted to count how many semicolons are in this listing so we can get some idea as to how long it is. I've never done this before. I wanted to find out how big TeX is. So it starts out with the program, and you'll see also that there's things in braces there indicating what module it came from. So if you can read the brace 9, that was because this code was generated by the compiler directives, which was module 9. And in module 9, it commented something out, and then that bracket there was a brace inside of a bracket. So then we get a program TeX, and it says label, and then the comment 6 says that those labels in the outer block are in module 6. So see how that works. Now let's see if I search for a semicolon. Now I'm going to search and see how many semicolons it can find. just to see how many semicolons are in this listing. But this is the way the Pascal program looks, and it's 45, 56 lines right now. It's all uppercase letters except where we have in strings. If somebody's Pascal doesn't accept uppercase letters, they would have to do system-dependent changes on the strings in quotes. You can see that text sources has a few lowercase letters there. All the lines are 72 characters or less. Okay, now it found 10,928 semicolons. So it's approximately 11,000 statements and declarations in this program, except that the word else also contributes. So if I search for else, I can find some more. So let's try else. And see how many occurrences of else there are in the program. 664. So that adds another. Okay, so approximately not quite 12,000 statements and declarations are in this program. The corresponding figure for sale tech was 5,000. So I'm just trying to understand the difference. Now sale tech used declarations. It would declare a lot of variables at the same time with commas in between them instead of having one line per declaration. So that might account for this. But if you want to know about the size of this compared to PTEC, it's a little shorter than the PTEC plus sysdep. So it's approximately it's actually gotten smaller than the existing version of TeX. So I believe the compilers will be able to handle it okay. Well, if there are any quick questions, I can handle them. Otherwise, we'll break for half an hour, and I can't see. Oh yeah, there's one. Oh, a format. You give identifier equivalent to another identifier. The first identifier is the one you want to be using. The second one is the one that you want it to format like. So I formatted debug as begin. I said format debug equivalent to begin, and that means that when text sees debug, it should enter a new level of indentation and put it in boldface like it does for begin. And backwards debug I made like end. And so usually when I define a macro, I'll just want it to be treated in the normal garden vanilla, the normal way that all identifiers are treated. But if I want some special treatment, I can say treat it like a certain Pascal reserved word. Yeah, the web manual is 8 pages long, so those rules are all given there in detail. But so at the very beginning, we have, as you know, in most programs, at the very beginning, there are features that are only used once. For understanding tech itself, those little fine points of web programming aren't going to be important. But if you want to know exactly what's going on, then those things do arise. Any other? Yes. Okay, the question is why use Pascal constants in some places and define numbers in others? And the answer is that I made Pascal constants in the places where I felt the user could change them at compile time and nothing else would go wrong. And so this was the distinction. This is, I think, a valuable distinction to have. So the things that are constant in that Pascal program, you should be able to change that number and recompile without doing anything to your web file or anything. To have the actual definitions, it was possible for me to get around a lot of of Pascal's restrictions. For example, Pascal doesn't allow you to have an array boundary that's something -1. And by declaring it as a web macro, I can subtract 1 from it, and Tangle will do the arithmetic, and it'll come out fine in my program. So that's why I've used web to get around these problems with the Pascal language. It's done correctly in Ada, and I wouldn't have had to do that in Ada. I might have done a different, and some other things.
What is the format of the changes file? How can it change things over?
Oh, the format of a change file that lines should match. See, can we get that up on? Let's take a look at TeX.change. We didn't use the TeX.change here, but now this is a page-oriented editor, and so the first page is an index to the rest of the index to the rest of the file, and so it shows you the first line of page 2, the first line of page 3, and so on. Here's page 2, which is the first change I made, and I just repeat verbatim a line that's in tech.web, and then I made a correction. So the first line matched. Then it goes on until the line that says @Z at the bottom there. And you see, my change here was only to put an S in the version number. It's a version minus 0.25S for Stanford, I guess, or SAIL or something, because SAIL stands for Stanford Artificial Intelligence Lab. And then these are index entries, by the way, here. Extensions to TeX. This @up arrow is something that goes in the index, and @up arrow system dependencies changes for SAIL in medium caps font. Every time I put something in my change file, I also put an index entry saying this is a change that I made, so that when I look at the index that I would weave from this, I could find all the modules that I've changed. Now the next module starts out with debug and backwards debug, and I copied it exactly, except that I did change it for debugging, so that it isn't braces, it's blank, and so on. So all of these changes just start out with a thing. Here I've used a special switch on our compiler, a W switch, which makes it catch the kind of errors that IBM Pascal catches that our compiler doesn't ordinarily catch.
So we should think about the change file as being merged.
That's the idea, that the change file is a small number of changes that will probably that you can keep on fiddling with until you get it to work with your present .web file. Then, when you get the real .web file later on, probably your change file will still work with it. And so all the system-dependent changes will do this. I could extend to multiple change files, but since we're listing all our files at the beginning of the Tango run, right now we only have exactly one web file and one change file every time we run Tango. Okay, so this change file is given on the tape that you get for TeX as an example of one change file that was done. I've made it here. If you look at, for example, the memory max has been changed to 1,000. That's not enough to do any user jobs for teching, but it's very good for debugging, because when you're debugging, you want the program to get into its complicated cases where it has to try hard to find free memory. Now I have that first happen a few months later. Okay, question over there.
You described all the lines in the web file which could change, get deleted.
Okay, yeah. So as soon as it finds a matching line like this, so Tango reads this first line into a buffer, the following parameters, and so on, keeps it in a buffer. Every time it reads in a line from the other file, from the web file, it compares those two buffers. If they agree, I think it'll do something like not care about blank spaces at the end or something. But if they agree exactly, then it starts reading the change file and continues the change file until it comes to @Z at the beginning of the line. It deletes all the stuff in the web file up till the beginning of the next module. In this way, you would be able to substitute more than one module for a your change file could generate 5 modules for only the one and the other. But we discourage this because then all your numbers will be off. And why do that? So at the very end, just before the index, there's a module called System Dependencies, and so that's where the system dependent changes. This module should be replaced by changes to the program that are necessary, and here's where you try to gather all of all of the changes that are going to require new modules to be made. That way, this will be the only one that changes the numbering system, and only the index then will really be misnumbered. Nothing else will bother you there. Okay, well, we better break now and meet again at 11 o'clock sharp for the second session. Thanks very much.